Okay, so yesterday we talked about SOHCAHTOA and just setting up the ratios of sides for sine, cosine, tangent, and then the reciprocals, which were cosecant, secant, and cotangent. So today we're actually going to start putting the angles and the sides together and understand how we can use angles to find sides and sides to find angles. So in the first question it says, given the triangle below, set up the three trig ratios of sine, cosine, and tangent for the angle given. Compare these ratios to the trig functions using your calculator. So yesterday I mentioned that we're going to start using, if you look at your calculator, we're going to start using these buttons, the sine, cosine, and tangent on your calculator. So that's what we're going to start doing today. So if you look, the angle that we are given is 53.1 degrees. So that's this right here. That's our theta. Okay. Well, if that's our theta, the first thing I'm going to do is say, okay, I know this is my hypotenuse because it's opposite the right angle. I know this is opposite theta, so that's the opposite side. And then this is next to theta, but not my hypotenuse, so that's adjacent. So first let's do sine. So we're looking at sine of theta, but instead of writing theta like we did yesterday, we now know that that's 53.1 degrees. So sine of 53.1 degrees should be, well, if you're thinking of SOHCAHTOA, remember the first letter tells you what your trig ratio is, sine, cosine, or tangent. Then the next two give you the fraction. So sine is opposite over hypotenuse. So in this case, that is 8 over 10. Okay, so we're going to take our calculator, and we have to do one thing before we do anything else. I want everybody to hit the mode key on their calculator. Okay, and if you notice, somewhere, obviously everybody's looks a little different depending on what calculator you have, but I want you to go down to where it says radian and degree, and I want you to click so that the degree is highlighted because we are dealing with degrees. Radians is another way of measuring angles, but we will not deal with that. You'll do that next year in Math 3. So you want to make sure that you're always in degrees. And you guys, if you do something in science, if you reset your calculator, whatever the case may be, you're going to have to come back and double check this, that it's always in degrees. So now that it's in degree, go ahead and hit second quit. We're going to do sine, okay, and it gives you the parenthesis of 53.1 degrees. Oops, might want the decimal in there. Okay, and you get 0.79968. Okay, so about 79968. Well, obviously we know 8 divided by 10, you could do that in your calculator, is 0.8. Now, notice how these aren't exact. That's because you have to round this. There's going to be a lot of rounding happening with these angles. You're very rarely going to get nice whole numbers or nice decimals. So because this is rounded, it's not exact, but 0.79968 equals 0.8. That's pretty darn close. So yes, that is what those are equal. So then we want to check cosine. So we have cosine of our angle, which is 53.1 degrees. If we set up our proportion correctly, cosine is adjacent over hypotenuse. So in this case, it's 6 over 10. So we know 6 over 10 is 0.6. So now we're going to take our calculators and get cosine of 53.1. And we get 0.6004. Okay, so 0.6004, again, they're not going to be exact, but that's really, really close, so that's good. You guys make sure as I go through this video that you're going through and doing this on your calculator so that you know how to use these buttons. Okay, the last one we're going to do is tangent. So tangent of 53.1 degrees. Tangent's opposite over adjacent, so in this case that is 8 over 6. Okay, so 8 over 6 is 4/3 or 0.13, or I'm sorry, 1.3 repeating. If I do tangent of 51.3 degrees, you get 1.33 something. Okay, so again, it's a little off because that angle is rounded, but you're close. So that is why all of these work. The ratios should always equal the sine, cosine, and tangent. And so because of this, we're going to be able to use them in order to find side lengths and find angles. Okay, so moving on to number 2. Number 2 It says a right triangle has a hypotenuse of 5 feet and a side length of 2 feet. Find the angle measurements and the unknown side length. Okay, so you guys, we're going to talk about something new on this problem. First thing I'm going to do is draw a right triangle in. Okay, so it says my hypotenuse is 5, so I know that's 5, and a side length is 2. You guys, it doesn't matter which side you pick, just pick one of the sides. Okay, well, the easiest thing to do is, I hope you're all looking at this and thinking, okay, Pythagorean theorem, I can find that missing side. So we have x squared plus 2 squared equals 5 squared. Okay, so we know we get x squared plus 4 equals 25. So x squared is 21. Now, in the last unit, you guys, we talked about when it's a side length that you really want to give us the decimal equivalent. Now, we're going to switch that on you a little bit in this unit because even though this is a side length, we want to look at it as x equals the square root of 21. Obviously, we would plus or minus that, but the negative wouldn't make sense because it's a side length. This can't be simplified at all. There aren't any perfect squares that are factors of 21. So this missing side right here is the square root of 21. Now, we don't want to round that because now we're going to use the sides in order to find angles. And if you round that, then you're rounding too early. Okay, so when you're dealing with sides here, unless it's your final answer, do not round it. So the square root of 21 there is perfect. Now, the other thing we need to do here is find the angle measure. So this is what's new for you, okay? So what you want to remember is that inverses find angles. So if you remember, think about, now a lot of times you guys now do this without even thinking about it, but think about if you're solving something like x plus 4 equals 7. You do the inverse operation, which would be subtraction. So you're trying to undo it, right? Inverse means you're trying to undo it. So in order to deal with an inverse, remember me saying yesterday that sine, cosine, and tangent on their own do nothing. They need to have an angle attached to them. Sine of something, cosine of something, tangent of something. So what you need to do first is decide what angle you're going to look at. And it doesn't matter. You just have to pick the theta that you want to focus on. Okay, so in this case, let's say I pick this theta right here. Okay, so once you've picked a theta, your second step is to set up the trig ratio for that theta. Okay, now according to this theta, this is opposite, this is a hypotenuse, this is adjacent. Okay, I'm going to use opposite and adjacent solely for the reason that if I have nice pretty whole numbers, that's what I'm going to use, but you can use any of them because you have any of the sides. So I could say cosine is square root of 21 over 5. I could say tangent is 2 over square root of 21, or sine is 2 over 5. I'm going to say that sine of theta equals opposite over hypotenuse. Okay? Now, if you do it that way, you're going to do sine inverse. If you picked cosine, you would do cosine inverse. If you picked tangent, you would do tangent inverse. So what that means, you can almost think of it as like you're taking the inverse of both sides. So to find theta, we want sine inverse of 2 over 5. That's how that works. So this sine is undone by the sine inverse, which is right there. So in your calculator, where are we at here? Okay, in our calculators, we are going to do, if you look right above sine, cosine, and tangent, those buttons, see how it says sine to the negative first, cosine to the negative first, and tangent to the negative first? Those are the inverses. So we're going to do second, we chose sine of 2 divided by 5, just like that. And that means that angle is 23.58 degrees. So theta is approximately 23 point, I already forgot, of course, 58 degrees. Okay, so I'm going to come over here and say, okay, now I know that this angle is 23.58 degrees. Okay, well, you don't need to do trig for the other ones because with the other angle, we know the three angles of a triangle add up to 180, right? So all we need to do is say, okay, cool, 180, obviously minus 90, minus the 23.58 that I just found, finds me my other angle of 66.42. So now you have all three angles and all three sides, and you're done. Okay. Now, this bottom question says, without drawing another triangle, compare the trig ratios with those of a similar triangle that has been dilated by k equals 3. Okay, so I touched on this yesterday, you guys. If you notice, all of your ratios that we were doing yesterday kept reducing. So whether we had a 7, 24, 25 triangle or um, 14, 48, 50, if we multiply that by 2, if we did 3, 4, 5 triangle, the last one we had a 9, 12, 15 triangle, they all kept reducing, okay? So if you think about it, the two things we said about similar figures were that angles were congruent and sides are proportional, and this is why. Your sides are proportional, so your sides can change, but your angles are never going to because the trig ratios will always reduce down to the same thing. I could multiply everything in this triangle by 2 and have 4, 10, and 2 root 21. Well, if I go to do my trig ratios, then I would get sine of theta equals 4 over 10. That's the same thing as 2 over 5. Okay, so your trig ratios will always be the same. And that is because the fractions will always reduce to the simplest fraction. So whether you have a scale factor, so the fractions that create the ratios will always reduce to simplest form. So you guys, the scale factor is just multiplying the sides out. Well, if you multiply them out, you can divide them back down to simplest form. Okay, and just a reminder, similar figures have proportional sides, so I don't care how big you make it, but because those ratios always reduce down, the angles will always be congruent. Okay. So I know it says without drawing another triangle. Whoops, sorry guys. There you go. But I'm going to anyway because I'm breaking the rules. So let's say we have a 3, 4, 5 triangle. 3 squared plus 4 squared equals 5 squared. And I found the angles of that. I can have that exact same triangle. I could have a 6, 8, 10 triangle. I just scale factored by 2. I could have a 15, 20, 25 triangle, right? It doesn't matter. If you look, if you start setting up ratios, they're all going to reduce down to simplest form, which would be 3, 4, 5. Okay, so that means this angle right here is going to be this angle right here, which is going to be congruent to that angle right here. This is congruent to this, which is congruent to this. Okay. All right, so on the back, we're just going to practice a little bit more. Okay. If you look at number 3, it says, given the triangle below, set up the 3 trig ratios of sine, cosine, and tangent for the angle given. Compare them to the trig functions using your calculator. Is this triangle possible? Okay, so if you look, we have our theta right here. Okay. We want all 3 trig ratios, so that means we have to do 10 squared plus x squared equals 18 squared to find that third side, because we're going to need all 3 sides in order to do all 3 trig ratios. So we get x squared, let's see, if we bring over our 10 squared, we get 224. Okay, so x is the square root of 224. Sorry, that's super sloppy. All right, so obviously we're going to look and see if that can be reduced. Okay, we want to reduce as much as we can here. The square root of 224, I think is divisible by 16 if I remember correctly. Obviously we got to play around with it if we're not sure. If you divide that by 16, you get 14. Perfect. So because this is 16 times 14, the 16 comes out as a 4, and the 14 stays in. So this side is 4 radical 14. Okay, so if we look, we have sine of, in this case, 56.25 degrees. That should equal, this is going to be my opposite, this is going to be my adjacent, this is going to be my hypotenuse. Okay, so if this triangle is possible, that should equal opposite, which is 4 radical 14, over hypotenuse, which is 18. Okay, so I'm not going to reduce that because that's not what the question's asking for. So again, work smarter, not harder. Okay, I'm just going to say sine of 56.25 gets me 0.83, about 0.8315. Okay, and then in your calculator, if you take the 4 radical 14, make sure you put it in parentheses so your calculator doesn't decide order of operations for you. Divide that by 18. You get 0.83, so pretty close, right? Again, it's not going to be exact. So 0.8315-ish, I think that rounds up. I can't remember. Yep. Okay, so far so good. The sign works. So again, now if we do cosine of 56.25 degrees, we get 10 over 18, adjacent over hypotenuse. So check those in your calculator. Cosine of 56.25 degrees and 10 divided by 18. Okay, so 0.55555, obviously 0.55555. So this is about 0.55557, and that is equal to 0.5 repeating. So again, close enough. Test the last one. We have tangent of 56.25 degrees should be opposite, so 4 radical 14 over adjacent, which is 10. Okay, so let's bring that over. So let's check that tangent of 56.25, and then 4 radical 14 divided by 10. So again, you're at 1.4966, 1.4966. So about 1.4966 on both. Okay. Okay, so since these are the same thing, 1.499966, just sorry. Okay, so see how this says, is this triangle possible? Well, the sine ratio worked out, the cosine ratio worked out, and so did the tangent. So because they all work, then yes, this triangle is possible. Okay, if you were to get a false statement, like 0.87 equals 0.62 or something like that, they have to be pretty darn close. Like you can start seeing that, you know, 3 or 4 decimal places are the same, then that's when you can say, okay, yeah, they're the same. But if it's anything off that, then you're probably looking at something that's not possible. Okay. All right, the next 3 problems are the same as number 2. We're just going to practice using that inverse. Okay, so if you start feeling like, okay, I'm getting a hang of this, pause the video whenever that is and try them, and then come back and check your answers. So if you look, number 4, you have a right triangle that has legs that are 19 and 4 inches long. Find the angle measures and the unknown side length. So our legs are 19 and 4. Okay, so right off the bat, we can use Pythagorean theorem and say 19 squared plus 4 squared equals our x squared, so our hypotenuse. We end up getting 377 equals x squared when you add 19 squared and 4 squared. If you square root both sides, just because I already worked this out, I don't believe I checked them all, that this is reducible. So that means your hypotenuse is the square root of 377. And again, just leave it so that you can use it. You don't want to round it and then not be able to use it in order to find something. All right, so Again, we need to find angles. So going back to the idea that inverses find angles, you have to pick your theta and then set up your trig ratio. Again, I'm going to focus on the two numbers that aren't the square root just because it's easier. So let's say I pick this as my theta up here. Again, it does not matter which theta you pick. Okay. Then this is opposite, this is adjacent, this is hypotenuse. Well, if I want to use the two sides that don't have the square root of 377, that's opposite and adjacent. Well, if you're thinking of SOHCAHTOA, the one that uses O and A, opposite and adjacent, is tangent. So I'm going to say tangent of theta equals, maybe that lets me let it go, equals opposite over adjacent, which in this case is 4 over 19. Okay, so again, inverses find angles. So what you're going to want to do is say, okay, well then theta is going to equal tan inverse of 4 over 19, because the inverse undoes that and gets the theta by itself. Okay, so by doing that, what all this is, you're going to pick up your calculator. Okay, again, remember your inverses are above, so second tangent of 4 divided by 19, and you get 11.89. So theta is approximately 11.89 degrees. Okay, so this angle right here is 11.89 degrees. And then if you subtract from 180, we know the 90 will bring it down to 90. If you get rid of the 11.89, the other angle is 78.11. Okay. So, a couple things, you guys. If you choose a different trig function, you're going to end up with the same theta, sorry. You can also say, okay, I want to find this theta down here first. And if you had done that, you still could use tangent. It would just be 19 over 4, and you're going to find the 78.16 first. So it's kind of like those geometric mean problems we did in the last unit. Kind of depending on the information given, you could start anywhere, and it was what you were comfortable with. Same thing here. The logical first step is to find the missing side and then do your trig, but your trig can be set up any way. You can use sine, you can use cosine, you can use tangent, and you can pick either angle because you have all three sides. Okay, so I'm going to do the same process down here for part A in number 5. We need our hypotenuse, so 11.3 squared plus 8.4 squared equals x squared. Okay, if we go through that all, we get 198.25 equals x squared. And then when you square root both sides, you end up with 14.08 is approximately x. So this is 14.08 meters. Okay. Now, because I didn't leave that as a decimal or as a radical just because it's ugly, I'm just going to make sure I use my other two sides to find my angles. So if this is my theta, this, oh, hello, how about that? All right, so because this is theta, sorry, this is opposite, this is adjacent, and this is hypotenuse. I'm just not going to use my hypotenuse. God, my computer hates me. All right, I'm not going to use my hypotenuse because I rounded it. So that leaves me with opposite and adjacent. So again, opposite and adjacent is tangent. So tangent of theta equals 8.4 over 11.3. Okay, so to find our theta, we're going to do tan inverse, tangent inverse of 8.4 over 11.3. Okay, so tan inverse of 8.4 divided by 11.3. Definitely did something wrong there. There we go. We end up with 36.63. So theta is approximately 36.63 degrees. So This is 36.63 degrees. Hopefully on yours you can get it in there a little better. My spacing is a little off. So then if we find the other one by subtracting, you end up with 53.37. So this angle right here is 53.37, and that's degrees. You guys, the degrees are important. It's kind of like putting meters, inches, whatever with a side. Degrees is an angle. That's what they're measured in, so make sure you get them on there. Okay. Hopefully at this point you can kind of start B on your own. So maybe pause it, find the side, use trig to find the angle, and see if you did it right. Here's my work. I'm going to find the side first. So x squared plus 6 squared equals 27 squared. Okay, when you go through that, you end up with x squared equals 693. When you square root both sides, 693 ends up being 9 times 77. So x is 3 radical 77. Sorry, that's super sloppy. This side right here is 3 radical 77, and that's in miles. But again, if you don't have to round it, try not to in case you need it. In this case, we don't absolutely have to use it. If this is the theta we're going to find, again, you can tell I normally go to the top left. It doesn't matter. You could start with angle B. But tangent, just kidding. It's not tangent. I'm just getting in a groove from before. Always check your sides. This is opposite, this is adjacent, and this is hypotenuse. Okay, so I'm actually not going to use tangent because I want to use my non-rounded sides whenever possible. So I'm actually going to use adjacent and hypotenuse, which means I'm going to use cosine. So cosine of theta equals adjacent over hypotenuse. So now, in order to find theta, because we used cosine, we're going to do cosine inverse of 6 over 27. Whereas on this problem, we used tangent inverse because we started with the tangent ratio. Okay, so now in our calculators, we have second cosine of 6 divided by 27. And that angle is approximately, 77.16 degrees. So if this angle is 77.16 degrees, that means if I subtract from 180, this angle is 12.84 degrees. Okay, so you guys, just a quick recap. On all of these today, I used Pythagorean theorem to find the sides first. Then you have all 3 sides, and then you pick your theta. Doesn't matter which one, just pick one and go with it. Set up one trig ratio for that theta, and it's yours of the choosing. I tend to go with the one that doesn't have rounded sides. Use inverse of whatever trig ratio you used to find the missing angle, and then subtract from 180 to find the missing third angle. Okay, so Pythagorean theorem to get your side, trig and inverse to find one angle, subtract from 180 to get your third angle, and you should have all your missing parts.